All right, so today we are really diving deep into the world of EEGs.
EEG.
And we're talking brainwaves, baby.
Yeah.
You know the stuff, the electrical signals in our brains.
Right.
And you have sent us some really cool research
Yeah.
on brain-computer interfaces.
Yeah.
So we're going full-on sci-fi today.
We are.
But for those who maybe aren't familiar,
Yeah.
what exactly is an EEG?
Okay, so an EEG is essentially measuring the electrical activity of your brain.
Okay.
And it does this through these little sensors that we put on your scalp.
Okay.
And they're able to pick up these tiny fluctuations in voltage
Ah.
that are produced by your neurons firing.
So it's like eavesdropping on the brain.
Exactly.
It's like listening in.
It's like listening in on the brain's conversation.
Yeah.
Exactly.
And so what can we learn?
The man.
Yeah, what can we learn from this eavesdropping?
Well, we can learn a lot, actually, because these electrical signals, they're not just random noise. They form patterns, and these patterns can tell us a lot about what's going on in the brain.
Okay, so what kind of patterns are we talking about?
So we're talking about things like different brainwave frequencies.
Okay.
So you might have heard of things like alpha waves or beta waves.
Right?
These are different frequencies of electrical activity.
Okay.
And they tell us about different states of the brain.
So is it like different brain waves for sleeping versus like working out?
Yeah, exactly.
Oh, wow.
So for example, when you're sleeping,
Yeah.
your brain waves are very slow and rhythmic.
Mm.
We call those delta waves.
Okay.
But when you're awake and alert,
Yeah.
your brain waves are much faster.
Okay.
And we call those beta waves.
Beta waves.
And then there's everything in between.
So it's a whole spectrum.
Yeah, it's like a whole spectrum of brain activity.
Okay.
And by looking at these patterns, we can actually start to understand things like,
Right.
how well is someone paying attention?
Oh, wow.
Are they stressed?
We can tell all that from brain waves.
Potentially.
Yeah.
Yes.
That's wild. Okay.
Yeah, and this is where it gets really interesting because this is where brain-computer interfaces come in.
Okay.
Because once we can understand these patterns,
Yeah.
we can actually use them to control devices
Whoa.
with our minds.
Okay, so it's like instead of using our hands or our voice,
Exactly.
we're using our brain waves to
Exactly.
like interact with technology.
Exactly.
That's mind-blowing.
It is pretty mind-blowing.
Yeah.
It's like something out of science fiction, but it's becoming more and more real every day.
So we're talking about like moving objects with our minds,
Potentially, yes.
controlling prosthetics,
Exactly.
all sorts of stuff.
All sorts of amazing things.
Wow.
Yeah.
This is incredible.
It's just the beginning.
I can't wait to dive in.
You too.
Okay, so we can eavesdrop on brainwaves. We can see all these patterns.
Right.
But how do we go from that to actually like controlling something with those brainwaves?
Yeah, that's the real magic.
That's where I'm lost.
That's where the algorithms come in. This is where computer science meets neuroscience.
Okay.
So, essentially, we use these algorithms to decode those brain signals
Okay.
and translate them into commands that a device can understand.
So it's like translating from brain language
To computer language.
Exactly. And you've sent over some research on some pretty amazing algorithms.
Yeah, I mean, some of these names.
I know.
Adaptive classifiers. Riemannian geometry. It's like, what is going on?
It sounds very complicated.
Yeah.
But the ideas behind them are actually quite simple.
Okay.
Let's take adaptive classifiers, for example.
Okay.
So imagine you have a BCI
Yeah.
that's connected to your brain,
Uh-huh.
and you're trying to move a cursor on a screen
Okay.
just by thinking about it.
Yeah.
Now, at first, the BCI might not be very good at it
Okay.
because it doesn't know your brain very well.
Right.
But every time you think about moving the cursor,
Yeah.
the adaptive classifier learns from your brain activity.
Oh, wow.
So it's constantly adjusting its algorithm.
To become more accurate.
So it's like, it's learning how I think
Exactly.
to then control the cursor.
It's like teaching your computer to read your mind.
That's wild.
It's pretty amazing.
Yeah.
And then you mentioned Riemannian geometry.
Yeah. That one sounds intense.
It's a mouthful.
Yeah.
But essentially what it does is it takes those brain signals
Okay.
and it maps them onto a curved space.
What does that even mean?
Okay, so think about it like this.
Okay.
Imagine you have a bunch of points on a flat piece of paper.
Okay.
Now, if you try to connect those points,
Yeah.
you might get a very messy picture.
Yeah, it wouldn't be very clear.
It wouldn't be very clear.
Yeah.
But if you could somehow bend that piece of paper
Okay.
into a three-dimensional shape,
Yeah.
you might find that those points actually form a very clear pattern,
Oh, wow.
like a sphere or a saddle.
So we're taking something that seems random
Exactly.
and finding the patterns by changing the perspective.
Exactly.
Wow. That's wild.
Yeah, and that's essentially what Riemannian geometry does for brain signals.
Okay.
It helps us to see patterns that we wouldn't be able to see otherwise.
And that helps us then control devices.
Exactly,
Wait a minute.
because now we have a better understanding of the underlying structure of those brain signals.
Okay, so we've got adaptive classifiers, Riemannian geometry. Any other crazy algorithms we should know about?
Well, there's tensor-based methods,
Okay.
which are even better at handling the complexity of brain signals.
Okay.
And then there's transfer learning,
Transfer learning.
which is the idea that we can use data from other brains
Oh, wow.
to help train BCIs faster.
So it's like my BCI can learn from you
Exactly.
to then help someone else even faster.
Exactly. It's like giving your BCI a head start.
That's amazing.
Yeah, it's a really exciting area of research.
It sounds like it.
Yeah.
Wow.
And then, of course, there's deep learning.
Deep learning, it's everywhere these days.
It's everywhere.
What is it doing with brain-computer interfaces?
So deep learning is really good at finding patterns
Okay.
in large data sets
Right.
and brain signals.
Yeah.
They produce a lot of data.
I bet they do. Yeah.
So deep learning is really well suited for this field.
Oh.
But there are also some challenges.
Like what?
Well, for one thing, deep learning algorithms can be very data hungry.
Okay.
So we need a lot of data to train them properly.
Right.
And that data can be expensive and time-consuming to collect.
Makes sense.
But despite these challenges,
Yeah.
deep learning is already having a big impact on the field of BCIs.
That's so cool.
Yeah, it's a really exciting time to be working in this area.
Yeah, you can say that again.
It feels like we're on the cusp of a revolution.
Absolutely.
Yeah.
So we've got these brain waves. We're turning them into signals that a computer can understand. What can we actually do with this? I mean, in the real world.
Yeah.
Yeah, I mean, it's cool to think about the algorithms and everything, but like, what can we actually do with this?
Well, the applications are pretty amazing. I mean, we're talking about things that could really change people's lives.
Like what kind of things?
Well, one area where BCIs are already having a big impact is in medicine.
Okay.
For example, helping people with disabilities.
Sure.
Like imagine someone who's paralyzed.
Yeah.
They can't move their arms or legs,
Right.
but with a BCI,
Yeah.
they could potentially control a prosthetic limb
Oh, wow.
just by thinking about it.
So they could walk again?
Potentially,
Yeah,
yes.
That's incredible.
It's pretty amazing, right?
Yeah.
And it's not just about restoring lost function.
Okay.
BCIs can also be used to enhance our abilities.
Really?
Yeah, like imagine a surgeon
Okay.
who could use a BCI to control a robotic arm
Okay.
with incredible precision,
Wow.
or a pilot who could fly a plane with their mind.
Wow, that's like straight out of a movie.
It does sound pretty futuristic,
Yeah.
but these are the kinds of things that BCIs could make possible.
Wow. So it's not just about like helping people who have disabilities.
No.
It's about like making everyone superhuman.
In a way, yes.
That's wild.
It's exciting.
It is exciting.
It's a little bit scary, too,
Yeah, I bet.
but mostly exciting.
Yeah. Well, this has been an incredible deep dive.
It has.
I've learned so much
Me too.
about EEGs,
Yeah.
about brain-computer interfaces,
Yeah.
about the future of, technology in our brains.
Absolutely.
It's really mind-blowing.
It is pretty mind-blowing.
So thank you so much for joining us.
Thanks for having me.
And thank you to you, the listener, for tuning into this deep dive. Until next time, keep those brainwaves buzzing.